All right, guys. So in this lecture, what we are going to look at is an overview of the medicinal chemistry, which is PCH 421, particularly the part that talks about drugs acting on hormones. Is that okay? Now, I believe that most of us already have an understanding of what an hormone is. We said hormones are substances produced or secreted either in the endocrine gland, e.g., the pituitary, the thyroid, the parathyroid, the pancreas, the adrenal, the gonad, or in tissues like histamine, serotonin, noradrenaline, adrenaline, and then released into the bloodstream, by which they are transported to other tissues where they selectively bind to receptor to exert their effect. That is what hormones are. Now we are going to classify hormones based on chemical structure. So if you are asked, classify hormones based on chemical structure. Based on chemical structures, hormones are classified into three. These are, we have steroids, we have peptides, and we have glycoproteins. Now, but this lecture, we are basically going to look at the steroids and maybe a little bit of what? The peptide. But the lecture is tailored towards the steroids. Is that okay? Now, let us look at examples under each of these classifications. Now, under the steroids, we have the sex hormones, right? What are the sex hormones? That is where you have the estrogen. That's where you have the progesterone. And of course, the last one is what? The testosterone. Is that okay? Now, under the steroid also, you also have the glucocorticoids. Are you getting it? And also the what? The mineralocorticoid or mineralocorticoids. And then we have the peptide. Under peptides, that's where you have hormones like insulin. In case you forgot any other one, you shouldn't forget insulin, because you were taught the insulin structure in your year 2 under protein. Another hormone that is also a peptide is glucagon. You know the opposite of insulin in the body is what? Glucagon, right? While insulin regulates blood glucose level, glucagon does what? Also regulate blood glucose level, but insulin tends to what? To reduce, while glucagon actually what? Increase. All right, so you should remember examples of peptide: insulin, glucagon. You also have others like oxytocin, of course, oxytocin. Then you have other ones like prolactin. All right, prolactin, the hormone that is actually found, or let's say vasopressin. Vasopressin. What is vasopressin? Of course, everybody know antidiuretic hormone, right? Which is ADH. Is that okay? Now, under this one, that's where you also have the angiotensin, where you have angiotensin 1, angiotensin 2. All those ones, they fall under peptide. And then the last one are the glycoprotein. As name imply, you agree with me that the glycoproteins are those hormones that consist of two components: the carbohydrate component, which is glycogen, and then conjugated together with what? Proteins. Hence, we call them the glycoproteins. Now, examples of the glycoproteins, that is where you have things like derivative of amino acids and fatty acid. That is why they call them the glycoprotein. Derivative of amino acid and probably proteins, you call them glycoproteins. Examples are things like luteinizing hormone. I believe everybody knows what luteinizing hormone is. You're going to learn about luteinizing hormone later on when we are talking about progesterone, talk about the chemistry of progesterone. You are going to learn what the function of luteinizing hormone is. We also have others like thyrotropin. Of course, you know, you're taught thyrotropin when you did it under drugs that are thyroid disorder, drugs used for treatment of thyroid disorder. Then you have the chorionic gonadotropin, the human chorionic gonadotropin, of course, HCG. That is what is measured to know if somebody is actually what? Pregnant or not. And then we have the follicle stimulating hormone, FSH rather. So these are the various classification of hormones and their various example. So if they say classify hormone based on chemical structure, you have steroid, you have peptide, then you have what? Glycoproteins. Under steroid, you have the sex hormones, which are the estrogen, progesterone, testosterone. Under peptide, you have insulin, glucagon, oxytocin, vasopressin, which is also called the antidiuretic hormone. And under glycoproteins, you have luteinizing hormone, thyrotropin, HCG, and then the follicle stimulating hormone. Is that okay? Now, having learned all this, the next thing you are going to learn is the two primary modes of actions of hormones. What are the two primary modes of actions of hormones? Now, what we are trying to say here is that hormone actually operate in two ways. Is that okay? Now, some hormones are believed to produce their action by activating the enzyme adenine cyclase. Of course, pharmacist students know what adenine cyclase is in target cell. Is that okay? Some activate adenine cyclase in target cell. Is that okay? And you know, adenine cyclase is actually present in the second messenger system, right? Second messenger system. Now, I do not wish to really waste time explaining all this here. If you want to have any other information concerning adenine cyclase, you can actually browse, but you know the exam is very close and you don't have that time, that luxury on time. And then you have the under those hormones that activate adenine cyclase in target cell, you have the adrenocorticotropic hormone, you have the insulin, you have the luteinizing hormone, you have the oxytocin, and then you have parathyroid and thyroid stimulating hormone. So all these hormones here, they work by activating adenine cyclase in the target cells. Adrenocorticotropic hormone, insulin, luteinizing hormone, oxytocin, and parathyroid and thyroid hormone. Now, other hormones induce enzyme synthesis by acting specifically on genetic material. All these ones, they may be objective questions. So one activates adenine cyclase. One activates adenine cyclase. While one acts by what? Binding directly to what? To genetic material, right? DNA and what? RNA. These are the two ways or two primary ways hormone actually work. One, by activating adenine cyclase, the second messenger system. You know, when you activate adenine cyclase, you have phospholipase this and IP3 and one other this thing. Then there will be opening of calcium channel and so on and so forth, right? All right. So that is the second messenger system. Now, also, some of the hormones that are actually here that act directly on adenine cyclase can also act on genetic material. So such hormones that act on genetic material, you have the sex hormones, right? You have insulin. You can also see there's insulin here. Then you have thyroid stimulating hormone. You also have the thyroid stimulating hormone here. Then you have the thyroid hormone itself, the glucocorticoid, and then the adrenocorticotropic hormone. Of course, you know the adrenocorticotropic hormone, they are synthesized by the what? Adrenal gland, right? The glucocorticoid also are synthesized by the what? Adrenal gland. You are going to learn about all this later. Now, let us look at the steroids very well. Now, what are the steroids? Steroids are a group of substances of both plant and animal origin possessing characteristics tetracycline backbone derived from where? They possess a characteristic tetracycline backbone derived from where? It is derived from cyclopentanone hydrophenanthrene. That is where it is derived from. Derived from, I specifically did not put it because I want you to take note of it. It's an objective, potential objective question. Derived from cyclopentanone hydrophenanthrene. All right, cyclopentanone hydrophenanthrene. Cyclopentanone hydrophenanthrene. Now, what is the phenanthrene nucleus? If you look at this structure very well, this is the stearine nucleus. This is the backbone of all steroids, and it is tetracyclic. Now, the word tetracyclic means it has how many cyclic structure? 4. Now, if you look at this very well, you agree with me, from here like this to this side, this 3 ring you see here is called a phenanthrene ring. Is that okay? It's called what? A phenanthrene ring. It's something like this. The phenanthrene ring is something like this. You have the something like this, and then yeah, this is how the phenanthrene ring looks like. This is what they call phenanthrene. It actually have double bonds inside of it. Is that okay? But because of the way I drew it here, I decided not to put the double bond. This is what we call the phenanthrene ring. So when you have a cyclopentane, if you look at this structure attached to this ring, is called what? Cyclopentane. Is that okay? This here told you that from this side to this side is called the what? Phenanthrene nucleus. From the red, phenanthrene nucleus. From the red part to this side is called the phenanthrene nucleus, plus the cyclo group. Hence you call it what? Cyclopentano hydrophenanthrene. Now why did you call it hydrophenanthrene? To tell you that they actually what? Added hydrogens to them. Do you know why? Because this double bond you see here, it is hydrogen that were added that made this double bond not to be here. It reduced the double bond to what? A saturated ring. Hence the name what? Hydro. To tell you that they added hydrogen to phenanthrene to reduce this double bond to only one single bond. Hence the name hydrophenanthrene. So if they say all steroids are a group of substances of both plant and animal possessing characteristic tetracyclic backbone derived from cyclopentanone hydrophenanthrene. Physical properties of steroids: they are white crystalline, they are insoluble in water but soluble in organic solvent, and there are few exemptions that are water soluble. Now their salts are generally water soluble. The salts of these hormones are generally water soluble. Is that okay? The salt of these hormones are generally water soluble. Now, having learned this, the next thing we need to learn now is the numbering. Now, the first thing you need to know is the numbering of the structure of steroidal hydrocarbon. Now, before you talk about the numbering of the steroidal hydrocarbon, I want you to take note of this mnemonic. It's very, very important. Is that okay? Very, very important. Now, the mnemonic is go east and play choline and cholesterol. This is the mnemonic. Take note of it. Go east and play choline, cholesterol. Now, this first one here, it actually means a particular compound, and that compound is called gonane. Is that okay? So if I want to bring it down here, go east and play, then we have choline and then cholesterol. Now listen, your understanding of this course and every other thing you are going to be doing span from getting this right. Is that okay? If you get this right, then it will be very, very easy for you to do well in this course. Now, this go means what? Gonane. It means what? Gonane. And it has how many carbon? 17. Is that okay? It's called gonane and it has 17 carbons. Now, east means estrane. And it has what? 18 carbon. So this estrane now is where you now get your estradiol. Is that okay? Estrogens. They fall under what? Estrane. So when they say draw estrogen, you know your mind will be going towards what? 18 carbon units. Is that okay? Then you have and means what? Androsten. Right? And androsten is how many carbon? 19 carbon. Now, under androsten, that's where you have what? Testosterone, the male sex hormone. Then you have this play. means what? Pregnane. Under pregnane, you have how many carbons? 21. So when they say draw the structure of progesterone, you know your mind should be going towards how many carbon? 21. Then you have choline. Choline is always choline, which is 24. And then cholesterol, this is where you get your cholesterol from cholesterol. And it has 27 carbons. Is that okay? Your understanding of this matters a lot to your understanding this course. Now, generally, how do you number this compound here? Now, listen. You can number this compound by starting from this position here. This is the position you usually start. And your numbering matters a lot because every other thing you are going to be talking about, when they talk about structural activity, relationship, and the rest, they're actually talking about the word numbering. So here, you have one carbon, which is carbon 1. Here will be what? 2. Here will be what? 3. Here will be 4. Here will be 5. You don't go up. You come here. Here will be what? 6. Here will be 7. Here will be 8. Here will be 9. Here will be 10. Then you start from here again. 11. And then, sorry about that. Where did we stop from? We stopped at here, okay? Yeah. Here will be 11. Here will be 12. Here will be 13. Here will be 14. Here will be 15. Here will be 16. Here will be what? 17. So this is how you number this structure. Is that okay? Now, let us take cholesterol, for instance. We want to talk about the isomerism associated with this compound. Is that okay? Now, we can put substituents at exactly position number 5 for cholesterol, like hydrogen. Is that okay? Now, if we put hydrogen at position number 5, what do you think we are going to be having? We are going to be having something like this. Hydrogen, right? And then you have another hydrogen substituent. Okay, this is not hydrogen. Now, cholesterol has here a CH3 group. First of all, before any other thing, let's understand something. Before I even talk about this cholesterol and the rest, let's just get an understanding. So this structure here is the steroidal nucleus, which is also called the stearine nucleus. Is that okay? This is called the steroidal nucleus, which is also called the what? Stearine nucleus. Is that okay? Now, listen. When this, how many carbons can you actually see here altogether? 17. Is that fine? Now, this position here can have substituents. This position here can have what? Substituent. Let's say this is arrow 1, this is arrow 2. This position here can also have substituent, which is what? Arrow 3. Are you getting what I'm saying? Exactly. Now, in a situation where arrow 1, arrow 2, arrow 3 are substituted with hydrogen, you call it what? You call it gonane. Do you know why? Because gonane has how many carbon according to what I said? 17. So if I put here hydrogen, put here hydrogen, and put here hydrogen, what do we call this? Gonane. Do you get it? You call this gonane. Now, listen. In the same vein, the gonane can be alpha gonane or it can be what? Beta gonane. Of course, you know, if you must complete the valency of carbon here, you will have to add hydrogens here. Now, most of these hydrogens that are added here are usually at the alpha position. Now, listen. This gonane can be alpha gonane and it can also be what? Beta gonane. Is that okay? Now, how do you identify alpha gonane and how do you identify beta gonane? Now, you usually use the position number 5. If you want to number, here will be what? 1, here is what? 2, here is 3, here is 4, here is what? 5. Now, if the line here at this number 5 connected to the hydrogen is dotted line, you call this 5 alpha guanine. You call it what? 5 alpha guanine. So whenever you see dotted line like this, you call it what? Alpha. Now, the same vein, you also have this particular one. Forget about this hydrogen here. This is not the ones we are talking about. The ones that we are interested in, of course, you know, this is also hydrogen. Then this is also hydrogen here. These are the guanine we are looking at. Now, listen. If the bond here is not a dotted line, but just more like a full structure like this, then you have hydrogen. You call this what? Beta guanine. What do you call this? Beta guanine. At what position is do you have the beta hydrogen attached? You have it at position number what? 5. Now, these are the structural activity relationship and everything we are talking about. So what do you call this? 5 beta guanine. Is that okay? So you call this 5 beta guanine. So that is everything you need to know about the guanine. We can have 5 alpha guanine, then you can have what? 5 beta guanine. Is that okay? Now, we are done with the guanine. So we can actually tick for guanine that we are done with it. The next one we are going to look at are the what? Estrine. That is where you now start having the extra methyl group attached. At what position? Position number, this position here. Is that okay? So we can decide to clean up these structures now and try for, let's attach the substituent for estrine. Estrine is having how many carbons according to what you have there? 18. Is that okay? If we are talking about estrine, for estrine, we are having 18 carbons, right? So, now listen, these hydrogens here will still be the same. So you have your hydrogen attached here. But what we are now going to do, if you number, of course, you can see what position is position number 18. This is 13, 14, 15, 16, 17. Here is what? Supposed to be 18. Are you getting it? It means we are going to add another, this thing, not 18 carbon, rather at position number, this position here, position number 13, we are going to add another CH3. Because if you look at the structure I told you earlier, that we can have substituent at this position, right? We can have substituent at this position, and we can also have substituent at position number what? 17. So if the substituent now is at position, if the substituent is at position number, at this position here, let's say you have CH3 attached to this position, it automatically becomes what? Estrine. So when they say draw the structure of estradiol, this is the first thing that will come to your mind before you even draw any other thing. Is that okay? Now, that is that. And then what do you have? You have your it can be alpha or it can be what? Beta, based on of course, you know, this arrow group also will also be what? Hydrogen, but you don't need to put the hydrogen there, based on the dotted lines that will be there. So if it is dotted line, you call this 5 what? Alpha estrine, right? Now, if the lines you have here are wedge structure or straight, let's say structure like this, or you can have them as straight line like this, you call this what? 5 beta guanine. All right, so that is, estrine rather, that is how you actually name all these compounds. Now the next one is androsten, 19 carbon. Now for androsten, what we just need to do is, in place of this substituent, no substituent can be at this number 10. In place of this substituent, what we are going to put is another CH3 group for androsten. So when they say draw the structure of testosterone, this is the first thing that will come to your mind, that you have CH3 at position number 10 and CH3 at position number what? 13 here added. So this will be the first nucleus you are going to draw before you start adding any other thing. Is that okay? And then you have pregnane. Pregnane is 21 carbon. Estrane is how many carbon? Estrane is 18. Androsten we just talked about now is how many? 19. So now in this case, what you are going to do is now for pregnane is 21. We already substituted for this position CH3. We already substituted for this position CH3 that gave us androsten, right? So this one in this case will be 5 alpha androsten. Why this one here will be what? 5 beta what? Androsten, right? Now for pregnane is 21 carbons. So what we are going to do is to attach 21 CH2 CH3 here. Is that okay? So when you have something like this attached here, automatically this thing now becomes what? Pregnane. Is that fine? And then this one also, CH2 CH3 becomes what? Pregnane. So when they say draw the structure of progesterone, you know you are going to have a structure that is similar to this. And then you have the next one, choline. For choline, we are leaving 21 to 24. It means we'll add more 3 to this compound we have here. So most times, if you add 3 to this compound you have here, C2H5, Abi, this C2H5. If you add 3 to it, to 3 carbon more, that will be how many? C5. Are you getting it? And then what? H10. This one will give us choline structure. So from here, you also have C5, H10, choline structure. And then the last one is cholesterol. Now, I really want us to look at that of cholesterol very well, because you are going to draw several structure or several reactions that involves cholesterol. Once you understand this basis now, I will just go straight to answering the past question, because you need to understand this before any other thing. Now, what you have here is for cholesterol. Of course, I told you, you have your CH3 here, you have the what? Hydrogen here. Here will also be what? CH3. It's already complete. Now, for cholesterol, you have a group that went this way, came from here to this position, then came like this, 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 came like this. Is that okay? If you count, this is 1, 2, 3, 4, 5, 6, 7, 8. Is that okay? 8 plus normal 19 that we have for, which of them has 19? Androsten. That will give us what? 27. So this is the structure of cholesterol, and this is where you have your what? Cholesterol. Is that okay? So when they say draw the structure of cholesterol, first of all, draw this ring. Is that okay? Then you now start adding your all group and maybe double bond if there is any need to be. So that's the basic foundation to actually understanding this course. The basic foundation. Now there could be ring enlargement and there could be ring reduction. There could be ring enlargement and there could be ring reduction. For instance, you have this structure here. What structure is this? This is your normal gonane structure. right? This is your normal gonane structure, right? Now what we have to do here is either to increase the ring or to what? To decrease the ring. So in this case, if I should put CH3 here, and then I put dotted line here, and then we have hydrogen here. Then here you have dotted line, and then you have Me, right? And then the question now is, if I should increase this ring increment usually come with the prefix homo and then indicating the ring. Now before we go ahead, you should know that each of these rings have a name. This is ring A, this is ring B, this is ring C, this is ring D. So for instance, from here, if we have a structure that looks like this, let's say you have this double bond, right? And then of course you have this structure, then you have this structure. Now, but this structure now, remember that this structure is supposed to be a cyclopentane. But if you are not having a cyclopentane, but rather you are having something like this, if you number this is A, B, C, D. Your methyl group still here, then your methyl group is still here, which is CH3. Every other thing still remains. Now, what do you think you are going to call this compound? First of all, when you have a dotted line like this, what did I say? Alpha or beta? Alpha. Now, but because the ring that was supposed to be 5 is now 6, you use the prefix homo, indicating which of the ring actually what? Enlarged. So in this case now it become what? D homo. At what position did it happen? Position number 5, the alpha substituent. So you say 5 alpha, and then generally before the ring enlargement, what compound do you think is this? Which of them has, normally this ring is 17 carbons, then 17 plus 1 2 carbons, making it how many? 19. Which compound has 19 carbons according to what we say? Say go east and androsten. So you now say this is D homo 5 alpha what? Androsten. Is that okay? So that is that. Now, how about a situation where this ring, last ring now, is now reduced? So instead of you having this ring A like this, you are now having it as something like, let's say you have something like this. You have your ring D, the usual way it ought to be, but rather your ring A is now looking like this. This is now your A, this is B, this is C, this is D. Of course, you know here you have CH3, here you have CH3, and then here you have your dotted line. So what do you think will be the name of this compound? First of all, we have to number. Here, I told you that number usually start from here, right? So you say here is 1, here is what? 2, here is 3, here is what? 4. Is that okay? So what do you call this one? You call it, at position number ring A, you have what? A shrinkage. Initially the ring is what? 6. If you see it here, this is the structure of androsten, right? Initially the ring is how many? 6. But now you are now having how many? 5. If you count, this is 1 2 3 4. This is a 5-membered ring, pentane. So this case now, you are now going to call this compound as A no. So instead of homo, you put no to tell you that there is a reduction in the ring. So when there's a reduction, you use no. When there's an increase, you use what? Homo. So you say A no. At what position is this bond now? This alpha bond is at position number 4. So you say A no 4 alpha Normal this thing is androsten, 4 alpha androsten. Is that okay? A non 4 alpha what? Androsten. Is that fine? Now, let us say a situation where a ring cleaved. There is cleavage of a ring. We are going to answer this question, but let's say there's a cleavage of a ring. Normally, cholestane is something like this. Let me bring it down a little. I told you cholestane is having how many carbon? 27, right? The rings are always like this. You know how to draw this structure. It's very, very important. You can decide to draw it this way. This 5-membered ring. And then, of course, told you that this one will come here, go here, come up, come down, go down, then it will come here. This is where you get your what is it called? Cholesterol. Now, of course, you have your CH3 group here. You must remember to always put your CH3 groups. Then you have this hydrogen. Now, what is the hydrogen telling you? What information do you think the hydrogen will give to you? That hydrogen, alpha or beta? This hydrogen like this, is it alpha or beta? Alpha hydrogen. Now, if there is cleavage in ring A, I just pray this whole structure doesn't wipe out. If there's cleavage in ring A, in such a way that ring A is no longer complete ring, you break it down. Normally, this structure is cholestane, 5 alpha cholestane. But because of this, at what position was the cleavage? If you want to number this, normally this will be what? 1. Here will be what? 2. Here will be what? 3. Here will be what? 4. Right? So you call it 2, 3, indicating the position where the cleavage took place. 2, 3 indicating the position where the cleavage took place. Then you use the prefix seco. 2, 3 seco 5 what? Alpha cholestane. Are you getting it? 5 alpha cholestane. So this is the way to actually go about the nomenclature of these compounds. Very, very important. Now, there was a question in the past question that says, how will you distinguish 3 alpha and 3 beta hydroxy? 3 alpha and 3 beta hydroxy. Now, there's something I want you to take note of. We have the OH derivative of parent hydrocarbon. This is more like the structure of what? Of cholesterol, right? Now, if I remove this structure here, and then I make this back to normal food structure, so I will erase this. If I make this back to our normal food structure, it has gone to the structure of cholestane, abi? Now, listen. If I decide to put OH here, initially you have what? Cholestane. That is why we call them the OH derivative. But at position number 3, I introduce OH. Our numbering is, this is 1, 2, 3. Is that okay? So this is now 3 hydroxy derivative. What do you now call this? Instead of you to call it cholestane, you are now going to call this as what? Cholestanol. Is that okay? Instead of you to call it cholestane, you are now going to call it what? Cholestanol. Is that fine? So that is that. Now, just listen and understand. We can distinguish between 3 beta hydroxy steroid and 3 alpha hydroxy steroid. Now, what does that mean? This OH you see here, it can either be this full structure. Like I told you, whenever you see a full structure like this, what information does it give to you? Beta. However, it can also be what? Something like this. which will be what? Alpha. Is that okay? So when the line holding the OH to position number 3 is a full straight line, you call it what? 3 beta derivative. In this case, this become what? 3 beta what? Cholestanol. If I remove this and it's now this, you call it what? 3 what? Alpha cholestanol. Now we'll be able to distinguish between 3 beta and 3 alpha by reaction with digitonine complex. It's an exam question, so you should take notes. As we are just going, we are answering the past question at once. So this is an exam question. The question says, how will you distinguish between 3 beta and 3 alpha hydroxysteroids? It's by reacting with what? Digitonine complex. Please take note. Now, when the 3 beta hydroxy derivative reacts with the digitonine complex, it forms an insoluble compound. Are you getting it now? So it's going to what? Precipitate out. Why? If it is 3 alpha plus the digitonine complex, is going to be what? Soluble. Take note. Beta will precipitate, insoluble. Alpha will be what? Soluble. So if you have a solution containing 3 alpha and 3 beta digitonine, all you need to do is to react them with what? I mean, if you have 3 alpha and 3 beta steroids, 3 alpha hydroxy and 3 beta hydroxy steroids, all you need to do is to react them with what? Digitonine complex. Is that okay? In such a way that the alpha will be soluble in the complex, but the beta will precipitate out. Are you getting it? In aqueous ethanol. You know, precipitation reaction, we usually add something, ethanol, to do the precipitation. So the 3 alpha will remain in solution. And the 3 beta, the mixture, you know, I told you that these 3 beta hydroxy will precipitate out in solution. The mixture of these 3 beta hydroxy and digitonine is what we call digitonide. So we call what? Digitonide. Mixture of 3 beta hydroxy and digitonine is what we call what? Digitonide. Now, if you react this digitonide with pyridine, it's going to give us the 3 beta hydroxy back again in good yield. 3 beta hydroxy back again in good yield. So the question is there, how will you separate 3 beta and 3 alpha? Is that okay? You've seen how you can actually separate them. I think that is everything that we need to know. Now, sometimes the ring may be saturated and it may be what? Unsaturated. Let's look at an example. I've actually talked about all this. All right. Now, which of the following steroid has 27 carbons? Is it gonane? Is it estrine? Is it colistin? Is it choline or pregnane? Which of them? So we have colistin, the correct answer, just to test your understanding. And then the next one, name for partly unsaturated hydrocarbon. Now, if you have some of the hydrocarbons that are partly unsaturated, for instance, if you have double bond here, double bond here, double bond here. Now, and then here, you have CH3. Now, ordinarily, how many carbons are here total? Look at the structure. How many carbons can you see here total? Normally, 17 from the ring, plus 1 here, making it how many? 18. 18, is it gonane or estrine? Estrine. Are you getting it now? So to name this compound, you call it the normal way of naming organic compound now. Of course, you know your numbering. We usually be from here 1, 2, 3, 4, 5, 6, 7. And it continues like that. So this one now will become Australia. Are you getting it? This become Austra. Position number 1, you have a double bond. So you say 1, 3. Position number 3, you have another double bond. Where do you have the other double bond? 5. 3, 5. Now, the double bond is between 5 and what? 10. As you can see. And the reason why you have to put the 10 in bracket is to tell you that there's actually a linkage between, there is a linkage of rings at position number 5 and what? 10. And the double bond is present in that linkage. Not just number 5, like number 5 coming this way. You know, this double bond, it can be 5 to what? 6. Are you getting it? You also name it as what? 5. But in this case, when they put 5 to 10, they are telling you that the bond is between these 5. Of course, here will be what? 8. Here is what? 9 and what? 10. So the bond is between 5 and 10 and not between 5 and what? 6. So you say Austra. And then you have what? How many double bonds you have there? 3 of them. So you call it what? Triene. So that is basically how to name this compound. Is that okay? That is basically how to name this compound. Alright, you can actually see the effect of conformation on rates and product of steroid reaction. Equatorial center is more rapidly attacked than East Asia epima. You know, definitely the structure of the both structure, the share and both structure of most of the structures are cyclohexane. You have some of the hydrogen pointed this way. You call this one what? Asia, right? Because this is cyclohexane ring. Now, each of these cyclohexane ring have Asia and what? Equatorial hydrogen. Are you getting it now? Equatorial center are more rapidly attacked than its Asia epima. Asia group are civilized more rapidly. You can go and read all those ones in page 3. Just memorize all those things there. Is that okay? So that is basically that for this particular one. We'll see in the next one.